Elasticity is a measure of a deformed object's ability to return to its original size and shape once the outside forces are removed. Hooke's law stated that the strain in a solid is proportional to the applied stress within the elastic limit of that solid. Hi, I'm going to do an experiment about Hooke's law. First, prepare this table. Apparatus are weight, spring, retard stand, and ammeter ruler. Set up the experiment. Here we have weight with a mass of 10 grams each. Measure the initial length of the spring. This will be the initial length. Next, add the weight of 20 grams to the spring. Next, measure the length of the spring, and then find the change in length by subtracting the final length with the initial length, and then record the data. Repeat the steps with the weight of 40 grams and 60 grams. We can see that the change in length is directly proportional with the force. Please follow the Hooke's law. Thank you.
For online simulation about our topic Hooke's law, we will use the applied force as the manipulated variable, the spring constant as a constant variable, and the displacement as the responding variable. And for the first simulation, we will use a formula F equal to Kx. And now we have a few tools that we can use during the simulation: applied force, spring force, displacement, equilibrium position, and value. And we can use this button to make two springs in same time. For both spring, we will set 150 for the spring constant. And we will start our simulation with 20 Newton. For the first simulation, 20 Newton, and the result is 0.133 meter for the displacement. For the second, we use 40 Newton, and we get 0.267 meter of displacement. And for 60 Newton, we will get 0.4 meter displacement. 80 Newton, we will get 0.533 meter displacement. And for the last one, 100 Newton, we will get 0.667 meter for displacement. Okay. For the second simulation, as usually we will use the wall toss that given, flat force, spring force, displacement, equilibrium and position. And we will set both spring constant into the lowest level. This is 200 and 200. And now we will use 20 Newton for the first measurement. For the second simulation, we will use the formula F equal to 2kx. And now 20 Newton applied force will result 0.05 meter displacement. For the 40 Newton, we will get 0.1 meter displacement. For the 6 Newton, we will get 0.15 meter displacement. For the 8 Newton, we will get 0.2 meter displacement, and for the 100 Newton, we will get 0.25 meter displacement. Okay. For the third simulation, the formula for the third simulation is F equal to kx over 2. And then, as usually, we will use the wall toss that given. And same like the second simulation, we'll set both spring constant to the lowest level. And now we will start our simulation with 2 Newton. 2 Newton we will get 0.2 meter displacement. For the 4 Newton, for the second Newton we will get 14 Newton, 0.4 meter displacement. For 60 Newton, we will get 0.6 meter. 80 Newton, we will get 0.8 meter displacement. And the last one, 100 Newton, we will get 1.0 meter displacement. Okay. For the last step in the online simulation is make sure that we record all the displacement as the result for this simulation that can be used in formula to prove our Hooke's law.
The force can compress the spring because the spring compressions. Once the forces are removed, the spring returns to the original shape. It is elastic. The elastic properties is this object or material make them very useful in various aspects in daily life. Can you see how the elastic property of some object is being used in the home? Name the elastic objects. The rubber band is elastic. The spring in the weighing scale is also elastic. Another band of the same weight is added to the weighing scale. We can see that the reading doubles. What happens when a load is applied to the spring in the weight machines? Notice the compression on the spring. We know that spring obey Hooke's law. This means the compression of the spring is proportional to the load on the spring. The larger the load on the spring, the bigger the compression of the spring. The spring is attached to a pointer that enables the weight of the load to be determined. The larger the load, the bigger the deflection of the pointer. Many sporting activities rely on the elastic nature of objects, for example, tennis. Can you tell how elastic is being used to play the game? Closely what happens when the ball is hit. The ball flattens slightly and the guard on the racket is slightly stretched. The tennis ball is elastic. The guard on the racket is also elastic. They will spring back into shape and cause the ball to launch off in the opposite direction. In all forms of transportation, the ride is made more comfortable by the elastic nature of cushions in the vehicle. How is elasticity applied to the bumper car ride in an amusement park? The bumper of this car are made out of highly elastic rubber.